All right, everybody, you're still here. All right. Hi, thanks everyone for sticking around. I'm Jason Huang with Qubole. Talked to some of you earlier, and I'm going to talk about Spark as a tool for machine learning and running it in the cloud. And so before I get to that, I have to give a bit of a background as to, okay, it still works, as to really what got us to this place. So from Qubole, our founders actually were the co-authors of Hive, which is actually the SQL tool to query massive amounts of unstructured data, as people know. And the idea is, when they were building out this infrastructure at Facebook, they were able to get a lot of people, non-technical people, non-database people, non-developers, say data scientists, marketing teams, ops people, people who really need access to the data to get to the data. And so what they did was they were able to get over 30% of employees access to this data without having to go through hoops of gatekeepers and whatnot. The key is they got to a point where they had to manage a team of 100-some people to manage this data infrastructure, okay? And so they thought, hey, it'd be great if we did something about this with the cloud, right? So I'm going to go into kind of the background of the cloud and really what's going on there, and then we'll talk about Spark and many of the things we know about machine learning, and then how it all fits in, and of course, we'll always have a little demo at the end, but that's that. So right now, research in the industry, Capgemini, Gartner, say these sort of things. It takes 6 to 18 months to do something with a big data initiative, right? It could be machine learning, it could be any sort of sentiment analysis, it could be aggregating massive amounts of data, it could be stuff coming real-time streams, it could be stuff from third-party aggregators for, like women just presented about, recommendation engines, who's buying what car, right? We can even go into the Internet of Things. We have streams from your Fitbit, all this data, how are you going to generate value out of this? 13% of organizations only achieve a full scale of production. So that means, if we do math correctly, since it's late, 87% say, we didn't quite get there. We got part there, we're still working on it. 27% of these initiatives are classified as successful. Again, more math, 73% said they didn't do all that well. And then 57% say it's a skills gap. I actually was in a different talk just earlier this week in Cleveland, and a gentleman was saying, hey, it's about getting people together. And I spoke with a gentleman earlier this afternoon and saying, there's just so many skills you have to know. Whether you're a developer, whether you're a data scientist, a statistician, whether you're a line of business, whether you're a marketer, or a researcher, there are so many things you need to know, and to talk to the right people to get it all to glue together is very challenging. So this is research that's out there in terms of where the industry stands. If we look at the tools that are being used, right now, this is something that we partner with some professors in the University of Colorado in Boulder, and this is what's being used right now in that data set. Hadoop's been around forever, MapReduce has been around forever, Hive's been stabilized, and of course, guys in the middle, Spark here, we're going to talk about in machine learning, is picking up. The key to this slide is not to say who's the winner, who's the loser, and make any guesses. The key is to say, people are going to continue using these tools for a long time. It's not going to be, hey, we now have one single winner, or this is going to be displaced. Now, I'm not going to say that organizations across the board are going to use all these technologies. That's not true. But I will say that organizations across the board will use at least 2 or 3 of these technologies. You're not going to just say, I'm just using HBase for HBase. I'm just using Spark, just Spark. Things are going to get mixed up, right? So that's really the idea, that how do you really scale given that there are many technologies involved. And by the way, these all have versions. As we know about software, there's different compatibilities. You're installing stuff. Your neighbor has a different version. You're running RStudio. Things don't work, the whole thing. So Apache Spark, we've talked about this a lot today. People have brought those things up. We have great demos. I think it was a really great turnout. It was built as an alternative compute engine. We had Hadoop in the past, but Spark here really allows you to do really interesting things with data sets, setting up data sets that you can actually store in memory and do inbuilt functions to do a lot of processing. The key here is there are sizable analytic libraries. The idea that you can do things with streaming data, say a live Twitter feed, say live information from a sporting event, live data from, say, Fitbit, right? I wasn't paid by that, just said Fitbit. Spark SQL, the idea is, well, once you have data sets, you might have stuff that has to be queried from, say, a Hive table. or traditional data source where you're doing SQL language queries to do table joins, to do aggregates, to do filtering and sorting. Machine learning, of course, this is why we're all here. You could do some really cool stuff with the Spark machine learning libraries. And then graph processing with graph libraries, relationships, and we've seen some of that as well today. Common use cases. This should be familiar to most people, but we can go over it. The idea that you have streaming data, things are coming in. Fraud detection, you're making a purchase. Do I flag that purchase on that card? Log processing, there's systems in place. You are running a business and you have to see are there security measures coming through in terms of is there unauthorized access to my machines? Is there something wrong in that processing of some sort of transaction? ETL for data ingestion, you're getting stuff off of a live stream from some third-party source. You have to do something with that. Machine learning, our favorite topic here. Anyone here in the room can come up and tell you this better than I can, so we'll just skip that. Interactive analysis, the idea that you may have to sit there and say, I don't know what I'm looking at quite yet. It's not a production run. I'm going to have a batch query. I'm going to say, select star on this table where I'm looking at a demographic of individuals who are near the, or Georgia Tech alums who are doing this sort of thing because I'm trying to start a meetup for this sort of thing, right? Interactive, just getting queries, information in and out of the system. You can do things in multiple languages. You can use R, you can use Python, Scala, and Java. So Spark provides a framework, but you can use whatever language of choice you want to interact with it. And then the idea of fog computing, the idea that a gentleman earlier presented, the Internet of Things, mobile devices, wearable things. There's so much information coming out from appliances, right? Your fridge is going to have data. Your TV definitely has data, but all these things have data. What do we want to do? How do we want to process it? We can learn about the temperature of our fridge for who knows what, but you could do it. So why Spark MLlib? Really the idea is you can actually combine the libraries I mentioned earlier and use them all in conjunction to do some interesting analysis, right? So there's other tools out there that allow you to process streaming data, a lot of tools out there to have you process ad hoc queries, a lot of tools out there that you have for other sort of analytic options, but within Spark, there's a huge ecosystem of the libraries that you can combine them all together and, in a language of your choice, put things together and really do some interesting analytics. That's just a screenshot of the Spark MLlib page. That's a bunch of the algorithms available for MLlib, and because it's going to be hard to read, I just took some and put them on a different slide. So this stuff, k-means clustering, which we're talking about in pretty much every presentation, is available, and I'll probably demo it for you. How about R? What about people who are using R and are running queries and analysis and models in R, statisticians who did the PhDs in R, have all these resources in R? You can use SparkR. What is SparkR? The ability to take stuff that's sitting in R, if you're running RStudio and you have data on your standalone machine and you have connections to other data sources, you can connect to SparkR, which allows you to take the data in R and use all the libraries in a Spark environment, manipulate it, do what you need to combine it, pull other resources in, and then you can pull it back to your R environment and do other sort of work, right? So really there's this bridge into the other systems. So you can do visualizations as well, right? If you're visualizing in R, but you want processing in SparkR, you can do the processing, bring what you need back, and then visualize it, right? There's a lot of interactivity there. And so again, you say, well, Jason, what about this cloud thing? You were saying this cloud, bunch of clouds. So the idea is, if we go back to the idea of, why did Ashish and Joydeep, the co-authors of Hive, leave Facebook? They said, hey, we can actually take the idea of all these compute resources, these Hadoop clusters, these, before they were Spark, but these big data resources, and separate the compute from the storage. The idea is you can have terabytes, petabytes, and apparently brontobytes now of data sitting in some huge storage thing, but only bring up the clusters to compute and do aggregations and run data models on the data when you need it, right? If you think back, to whatever time slice you want of technology, there's always been some big machine running 24/7, and it's, maybe utilized 10 to 20% of the time, right? Email system, database servers, whatever you want to talk about, whatever time slice of technology you want, stuff is just running idle until someone logs in. The idea is to bring stuff up and down when you need it, right? The elasticity model. I might have a query or a linear regression that will take 4 nodes. Someone else might need 40 nodes, right? Can we share those resources together? Can I piggyback my resources on the individual who's using 40 nodes and share that resource? And if we're both done, finished, can we have the cluster come down? What about having governance, right? How about if there's data that I shouldn't be able to see? How do we kind of separate that out? How do we actually scale it up so that, if there's end of the month reporting, right? If there's a huge holiday thing coming, we're trying to do huge sentiment analysis as to what is going to be the holiday toy of the year. Where are we going to put all our marketing dollars? That's going to take more power. And after that, it's going to quiet down. Okay? So if you run Spark in the cloud, you can have 0 configuration. Everything's already, I started 10 minutes ago. Yeah, I have a timer here. You have a configuration in the cloud where you don't have to install these libraries. They're already installed in the cluster for you. You can submit a SparkR program via an API and have an on-demand cluster come up. You have nothing running in the cloud, and the thing just comes up by itself. You can do ETL, right? If you have other sources of data, it might be an HBase, it might come from a Hive, it might come from some other source. You could do ETL using those tools in the cloud before you're running your k-means clustering algorithm, before you're running your before you're running any other machine learning data models, right? So the idea is you're in one location and you can run multiple tools on that data set before you need to run your machine learning algorithms, okay? If you have an object store, files are sitting there. Storage, say S3 for the Amazon world, is highly available, highly scalable, highly reliable, and cost-effective. And then you can just scale up, say, EC2 instances to compute when you need 10, 100, or 1,000 compute nodes. You can actually have multiple clusters for multiple teams. If you have a test environment, you could have a test cluster. If you have a production environment, you have a production cluster. You can mix and match. This is what S3 is like, another screenshot. So I put the example MLlib stuff on my S3 bucket for a quick demo. Depending on your workload, you might have to have, hopefully not Bronto bytes yet, into a massive memory structure, right? Because a lot of data needs to be cached in memory. But if you're doing a lot of high compute-intensive analytics, you may not need so much memory, but just larger core counts, right? You can choose what kind of resource you're using to compute those analytics, those machine learning models in Spark. And then there's some health management of clusters when they go up or down. So the do-it-yourself version is you can install Spark on EC2. You can choose if it's running standalone, if there's a cluster management layer like Yarn or Mesos, and you start a cluster up. The good thing is there's scripts out there. There's EC2 scripts that the Spark Apache project has that you can spin up clusters. You have to set up your security groups. There's Spark installed, and you set up your VPCs and whatnot. The other way is to do it the Qubole way, which is the short demo. Let's see if this works. Okay. And I have 3 minutes left, so let's see if I don't break. Wait. Okay. Let's see. Where'd my short demo window go? Telling me to fly home. Okay. So, yes, I have a flight tonight. Okay. Oh, that's now my other reminder to fly home. Okay, so the other way, the not do-yourself way, is to have something like Qubole have a service where you just log in and we bring up AMIs with all the Spark components in your EC2 environment, so you can just run the algorithms, the analytics, without having to deal with the infrastructure, right? Most of the people here are data scientists, statisticians, researchers. You don't want to play with configuring computers. You want to say, hey, cool, I have this Python code, and I'm running it, and I figured out Spark. I have this piece of code here that figured out the Gaussian mixture of this data set that I have. And this is running in Python as well. You want to say, great, I also have, where'd the other query go? I had another one here somewhere. Oh, here's the k-means clustering example I had that's running in Scala, right? So from one window, you can say, I'm running in Scala, in R, in Python, and I have all these results using the Spark MLlib libraries to run on my data set to figure out, well, here's the information I want. I don't have to worry about having resources available. I can just go and click compose and pick Spark command and put in what I need to put in, and my data is sitting on S3 in a data set. And so you'll see here, all I had to do was say, hey, here's my file sitting in my bucket with this example, and this is from the Spark download. K means data set, right? And I just ran it, and I got my results. And I had a kind of a history of all the queries, so I actually also ran a logistic regression. I actually also was able to pull data from a Spark table, right? The idea that I'm running R, I have a Spark table, a Hive table, and there's data there. Let's pull that data in and then, run analytics on it in Spark. So I think that's my time. Thanks.